Hi there, my name is José Barbosa, and we're here to talk about SCADA, piscada. So we're going to talk about piscada software architecture. This applies in the first part mainly to the piscada master, so the unit that runs the central SCADA solution. The foundation is the Raspberry Pi Linux implementation. It's a very stable solution, very well applied in the real-time world, and it's the base for all the solutions that using Raspberry computers. On top of Raspberry Pi, we have implemented a relational database management system, the MySQL version called Maria DB. This holds all the information about the definition of digital data, analog data, counters, etc. It also keeps the alarm pages valid. It does the data logging, so everything that has to do with retention of data is done within this database. This block can run in a separate CPU, so the piscada software could be running all of it in a single Raspberry Pi, but the Maria DB, for example, together with the database editor, could be running in a separate CPU to guarantee higher performance if needed. The colors on this scheme indicate exactly that. The things that could be running in different CPUs are colored differently. So again, Linux, real-time database, on top of it the MySQL. Probably shouldn't call it the real-time database, because what actually happens in the system is that all the data that is inside the relational database management system is at runtime copied and transformed to a real-time database in memory, and that's the one that actually is used during all the execution of the code. This applies mainly to real-time data, not to the data log, which is actually written into the MySQL as well as the alarms and things like that. Okay. So most of the applications are written in Python, and so it runs on top of the MySQL database as well. And the communication across the network can be done in different forms. Most of the real-time data is transferred using a publish-subscribe solution over IP with a protocol called MQTT. MQTT uses a broker, which is called a Mosquitto broker. It is also an open source solution, and this Mosquitto broker itself, again, could be running in a different CPU, and you can even have different instances of the same broker to apply to larger installations. So the capability of expanding in size becomes very important. The system itself also responds to HTTP requests from the network, and these are mainly used for a couple of functions inside the network itself and for communication with the user. There's a definition of a set of REST APIs that are used for the communication with the RTUs. The very first one is called RTU config. This is how an RTU, when it powers up, requests from the server an identification of who am I. He indicates, the RTU indicates what his MAC address is. That MAC address will be registered already in the database, and based on that registry in the database, we're going to tell the RTU what he should be doing. Then there's a second REST API that is called by the RTU once he knows what it's going to do, and this is the signal configuration. Signal configuration is going to have the detail of all the I/O that particular RTU is going to be using, and this is also stored in the relational database. Once that action is done at the beginning of the booting of the RTU, then the RTU starts running on its own. But these configuration can be let's say, redone or forced to be reloaded by the piscada master by requesting the RTU to do a reboot and reload of database, or by the RTU himself if he has a power up again or a watchdog action that makes him restart. So anyway, the REST APIs are called at startup of the RTU. Then the system has also a what is normally called a LAMP, Linux, Apache, MySQL, and PHP setup that will allow us to respond to HTTP requests from the network as far as web pages. So in this particular case, we actually have a website generator with the tool called Joomla that creates a monitoring solution for the SCADA master that can answer directly from the network, from any browser on the network, with a preloaded and well-defined user interface. Final note here to the user interface for a more flexible solution. So the tool called Node-RED is extremely powerful and allows us to create screens, SCADA screens like we're used to see in SCADA systems, with all the indications and of the variables that the user has. So the idea is to preload this Node-RED with several SCADA screens, and then we open that to the design of the user or the integrator to design whatever screens you want to use with the Node-RED tool, having access to all the information of the data in the database itself, but also directly of everything that goes in the publish-subscribe network, and also to be able to implement other things like gateways and connections to other systems. All that can be done within the Node-RED is an open window for external systems. Thank you for watching.